Oops, I'm on mute. All right. Welcome, everybody, to another great episode of Howdy Partner. My name is James Spencer. I am a Partner Solutions Architect here at AWS. And joining me today is Jerry Tejada. How are you doing today, Jerry?
As James said, I'm Jerry Tejada. I'm also a Partner Solutions Architect at AWS.
Nice. Good to see you. A good first timer. I'm happy to have you on here. It took me a while to drag him on the show, but he made it.
Yeah, but we're here. We are here.
So in case you've just never seen Howdy Partner before, Howdy Partner is our weekly show, live streaming show we do as part of the AWS Partner Network, where we bring partners on and they show us what differentiates them, how they make your lives better, what they can do for you to help with everything, make your infrastructure cleaner, more resilient, highly available, you name it, we got it. We want to show them, we want to go past the diagrams, we want to go past white papers, we want to see things in action and hear it straight from the experts who built it, because they know it better than me, for sure. They know it better than probably everybody, I would hope so. So with that said, so a little bit today we're going to talk about is some of the AWS shared responsibility model. Big part of it. Jerry, I don't know. I'm pretend I'm not wearing this shirt. What is the AWS shared responsibility model?
Yeah, definitely. So security and compliance are a shared responsibility between AWS and our customers, right? So the way we like to think about it and talk about it is there's security of the cloud and security in the cloud. So AWS on our side, we're responsible for security of the cloud, and that's the underlying infrastructure that's built on these services. But security in the cloud, that is the customer responsibility. Now, part of that responsibility is high availability and resilience, which we're going to talk a little bit more about today.
Awesome. Yeah, definitely. Those are important, because if people can't get to your stuff, you're not making money. Like, why are we in business? We got to get to your stuff. So joining us today, we have our friends and partners from Vertical Relevance. Let's go ahead and bring them on, get them ready to go. We are joined by Austin McMillan and Jim Hourihan.
Hey guys.
How you doing today?
How you guys doing?
Great. Hot, but
We're ready to rock.
Yeah. So Jim, tell us a little bit about yourself.
Sure. So I'm a managing partner here at Vertical Relevance. What does that entail? So I primarily drive the account relationships with AWS. So both AWS account management, AWS ProServe. Obviously it's all about driving, proper consumption and engagement with ProServe, and then more importantly, making sure that we deliver for AWS end customers. So primarily business development and account management for Vertical Relevance here.
Awesome. Cool. Good to have you on. Austin, how about yourself? What's up?
Thanks. Yeah, so I lead the SRE and resiliency practice that we have here inside of our AWS practice at Vertical Relevance. I wear lots of hats. So I do a lot of customer delivery. I worked with lots of our customers in the past, all inside the space. I also assist Jim in a lot of dealing with our clients and things like that. I do a lot of delivery oversight and make sure that we're delivering what our customer wants us to. But then the passion is driving us forward as a firm to be kind of bleeding edge with all things resiliency and SRE. So it's kind of my role here is to let's be as strategic as we can and see what our customers are dealing with, where they need to go to, and how can we get them there, and what can we do that really drives them into the next phase of excellence.
Awesome. Yeah, great. And for all you out there viewing today, please let us know you have any questions, any comments, drop them into the chat, slam that like button. I'm going to go with the old bystand thing of I heard 60% of you aren't subscribed, so please follow and subscribe, get more great info like this, and interact with us, ask us questions. If a cat walks on screen, say hi to the cat. I don't know. You never know what happens on this kind of stuff. With that, Jim, I think we're going to talk a little bit about VR as a company and as a partner.
Sure. Let me, if you don't mind, just spend a little bit of time on Vertical Relevance, our relationship with AWS, and then most importantly, set the context for some of our reusable solution accelerators, which will tie into what Austin will be demonstrating today in later in the studio. So, Vertical Relevance, we are a boutique technology consulting firm.
Let's go ahead and toss up the screen real quick, if that's okay, James.
Oh, okay. Yep.
Yeah,
Thanks. Appreciate it.
Yeah, I got you.
So, like I was saying, we are a boutique business and technology firm. We are AWS and AWS only, so we are not generalists. We are very focused on AWS services, and then building out our domain expertise, our competencies. You'll see some of our assets and accelerators all around AWS. So we are primarily focused on financial services from a domain expertise. However, we just most recently have gotten into telecom, so the likes of AT&T, Verizon, TELUS in particular, and then we're also working in the media and entertainment space. So those are two new verticals in addition to financial services. We've been working with AWS in financial services for probably about 5+ years. And those are very strategic, large banking clients, insurance, global payment providers, credit card and payment providers, and then asset management. So you'll see the key verticals and domain expertise down there in the left corner. So not only do we have AWS, capabilities and engineering capabilities, but in addition, we have subject matter expertise in financial services. So what does that bring to the table? That allows us to understand from a business perspective what that client might be, up against, or what the opportunity may entail. And it's just good to understand a customer's business. So we pride ourselves in understanding what business outcome they're trying to drive, and then obviously more importantly, understanding the underlying business as well. From an AWS perspective, we are part of the partner network and advanced partner. We have several competencies you'll see up on the right. And the way we're organized, we have 6 competencies you'll see in that triangle. And so, if you look at the foundational components, right, DevOps, building out landing zone and control towers. If you look at security, building your security pipelines, this has come up to the forefront as a must-have most recently. And, both Austin and I and the other solution partners are starting to see a lot of activity around security in particular, and security guardrails. And then we'll get into SRE and resiliency, another must-have, as you can guess, across the customer sets and the segments that we see, incidents are not healthy. How do I help the customer to protect, be more resilient? And we'll get into some examples, how to utilize our capabilities from an SRE and resiliency perspective. And then as a customer matures, we see a lot of work around migration, monolithic applications moving to modernization, and then all things data. It's at the forefront right now with not only data analytics and data pipelines, but as you can guess, Gen AI, and how do you build an ML ops framework for Gen AI. But one of the things I do want to make sure I get across is that we built the company based on our domain expertise, competencies, and then what we call our reusable solution accelerators. And Austin will get into some of the RSAs that pertain to SRE and resiliency. But these are code-based assets that we bring to bear to reduce time, cost, and risk of an engagement. So these are assets that we bring to our engagements. They're not products, but it is an evaluator and certainly an accelerator for some of the engagements that we see across ProServe. So with that, I'm going to turn it over to a very capable solution partner, Austin, who is very entertaining. I'm not sure if he's going to tell any jokes during in his presentation, but
let's hear some jokes. Definitely.
I'm feeling the need to pull up some XKCD at this point or something. I don't know.
A lot of pressure.
There's always a relevant one.
Yeah.
No pun intended with vertical relevance, right? So
yeah. That's so cool. I do DevOps competency reviews. We can't see my face really, but and so I love that. That's so cool. And chat, I dropped in if you see across the screen there, everything we're going to show today, if you want to preview, go ahead and check out that link. I dropped it in the chat too. Austin, back to you. Sorry about that.
No, it's great. So yeah, I'll just jump into this, right? And I'm going to keep the slides to a minimum, right? And because I think we all hate slides because we work in corporate forever. So we'll keep this tight. But we even just put on the AWS definition here from the well-architected pillar for resiliency. We figured, hey, let's start with AWS content. So, what is resiliency, right? It's the ability of a workload to recover from infrastructure or service disruptions, right? I mean, we all kind of know what it is, right? Crap happens. We've got to fix it. We've got to make sure that it happens in a way, it's fixed in a way that nobody knows. I think one of the things that's challenging is like people like ask me what I do. And I'm like, first off, I'm in the clouds. That's hard to describe. And then I'm kind of like, I'm also in the cloud and I'm making sure that if something happens, you just don't know. Like if my life isn't here, like, people wouldn't even realize it. So, but, we go through and like, why do we need to do this, right? Why does it matter so much? So, there's a lot of reasons why we need to make sure we can gain confidence in finding unknown risks, finding the unknown unknowns. And we talk about that a lot with our customers. People really just don't know what's going to happen. And so it's our job to help them figure out, hey, by the way, when you like start adding 5% packet loss, this is what happens, right? They just have no clue, right? When we start talking about resiliency. We really want to make sure that we can evaluate the targets. What's your RPO data loss? What's your RTO downtime, right? Your different non-functional requirements. You're going to hear me say NFRs a lot today. So, just apologize if you guys non-functional requirements. And then we're going to identify and resolve issues before they occur in production. That's clearly a piece of it. And then obviously we want to really improve operational efficiency, right? These are the kind of the outcomes that we're trying to get by making sure that we can respond to any kind of failure in any kind of system. So what we have here is kind of a five or a 4-step approach that we just want to talk about. We'll kind of, as we look at the solutions we built, this isn't about this so much. This is like, how do you get there? What's the journey that takes you to that space? And it's around these 4 pieces that work together, right? You have to find solid requirements, right? Good standards. You have to build the right frameworks that help you to enable and actually get those requirements in an automated way. You got to continuously improve, and you got to make sure that your people come along for the journey, right? You do those 4 things, and you're going to be operationally resilient. We're going to talk a lot in that frameworks and action piece, right? Let's build those frameworks. We'll talk some about some requirements, continuous improvement, things like that. But that frameworks, I think, is why we're here today mostly, James, to kind of discuss. Any questions about any of this so far? I realize I'm just kind of blowing through this before we dive into more interesting things.
Yeah, Austin, if I could add, some of the questions that we typically ask customers is, how critical is uptime and reliability? What type of incidents have you had most recently? What is the impact on your business? And that typically draws out a good conversation around, SRE resiliency in particular. So just wanted to add a little bit of color there.
Yeah, I was going to say, especially what Jim said earlier, if one of your primary focuses is fintech, resiliency is like an absolute 1,000% must, because your stuff goes down or you can't get it back every second that you're not up. That's just, I see the chart like just going, stonks are going down,
Yeah.
So
Yeah.
Like of all, I mean, everything of course is important. It's always good to be resilient, but fintech is probably like, you don't want to lose any of that stuff.
Right. So how do I mitigate the impact, right? That's the most important aspect of this.
I've been in the technology space for a long time, in the cloud space for a real long time. And this is the first time when I got to fintech and I was talking to customers, like, tell me about your requirements. And they said, oh, an RTO of 0 and an RPO of 0.
Wow.
It was the first time I'd ever heard it. And then they told me why. And they're like, hey, they have to do 10,000 transactions a second at 250 milliseconds a transaction. And for every transaction that either doesn't make it or is over that time, there's a financial hit for every single one. So if they're down for 5 minutes and it's 10,000 transactions a second, they take a financial hit on how many hundreds of thousands of transactions.
God, that's incredible. I never heard those numbers.
So the volumes are just crazy. So you get in there and you're like, okay, well, RTO and RPO of 0, let's go, right? Like a lot of it comes because of those requirements. Yeah, sorry, Jerry?
No, when you put it that way, it just totally makes sense. You know, when you give that, because you can say resiliency is important in financial industry and this and that, but when you give a concrete example like that, it's night and day. You can just see the value right away.
Yeah. It's all of a sudden we're like, people are like, oh, active, I can't pay for that. And then they're like, oh, I think, no, I can't afford not to, right?
Yeah, right.
Exactly.
Me and Jerry, we do workload validation reviews, and part of those reviews, we actually, part of it is tell us your RPO and RTO, and some people will have like 24 hours or 10 hours, and I mean, technically that's still, as long as you've established your business needs, like, and you explain and justify them to us, like, well, that control will pass. But in my mind, I'm like, if I play a video game and the game's down for an hour, like, people are looking for blood. How are you going to have an RTO of 24 hours or whatever? I'm like,
that seems like an eternity at this point.
You wanted to transfer some money in your bank account? Wait till tomorrow.
Oh God. Yeah. Sorry, I'll stop now. But man, like, zero, that's awesome.
So, what we kind of get here is, what are the design principles in order to do this? How do you do this at scale, right? We're talking enterprises, hundreds of applications, thousands of applications, some 20 plus business units. So we kind of talked about these 4 different kind of design principles when you're building these frameworks. And the first one I'm going to go through is extensibility and adoptability. Whatever you build has to bridge that gap between enterprise generic that can be made application specific. And that's really hard to do, but you got to do it. And the closest way I see you can do that is you got to build everything in code. Testing is code, right? Standards is code. The more you can make things as code, the more you get your developers involved, the better you're going to have that thing to be adoptable and extendable by your organization. We'll get into accountability and reportability, right? You got to make sure that you can have some governance. Nobody's going to pay for it otherwise. So you want to get the executives on board, make sure that they are able to see it, that they can report on it, right? And kind of get them the governance that's required. Deep domain expertise, absolutely essential. You got to make sure that you understand the topic really, really well. You got to go really deep. If we're talking about resiliency today, you got to go really deep in resiliency. And it can't just be surface level, right? A lot of times you hear resiliency and you just think it's all it's about is introducing failure, or right, things like that. And we're going to kind of show you how deep you can actually get into that space. And then the last one is you got to make sure you're really adhering to all those SRE and DevOps principles. Automate everything, fail fast, right? High quality, high velocity delivery, right? All of those kinds of principles that kind of tie into that. So anyway, what we showed today, and the RSAs, our solution accelerators, are going to hopefully identify and show how we've tried to have these kind of in our mind as we've been designing all of these solutions. So. Okay. We're going to get into an actual architecture diagram. Can people kind of see that? Is that a little small?
It's a little small. I can make it out, but I'm used to those icons. So
yeah. Hopefully.
Okay, there we go.
Icons look similar. So we're going to talk about specifically from what does resiliency start to look like here. And actually, let's hide the screen for just a second, if that's okay.
Sure.
James, yeah. I'll kind of talk through this here with 4 of us for a second. So we kind of want to talk about this journey of what it takes to get to resiliency. And the first piece really is you have to have everything built on a strong observability stack, right? If you don't know what's happening in your environment, you're just totally in trouble. So we've had customers who come and talk to us and they're like, hey, we're really interested in resiliency. We talked, and then we find out that their observability stack just isn't cutting. We're like, that's great. And unless I can actually see what's happening, I can't actually tell you if you're achieving what you want to do. And then from there, once you have that kind of in place, then you want to start saying, can you actually do what you need to from a performance perspective, right? Can you simulate production, right? And so we kind of have this whole conversation. We actually have a solution that is around this intelligent capacity evaluator. We're not going to get into it too much today. We got other things to talk about, but think about it as a way to do performance testing where the tool tells you what the capacity was rather than you trying to find it out. I don't know how much you've been into performance testing or not, but so often performance testing feels like you're shooting from the hip, right? Let's see if I can handle 50 customers, 100 users.
Oh, yeah. Okay, I see where you're going. Yeah.
Instead, what we have is a tool that actually, it will monitor while you're performing the test, it'll be like, what's my error rate? And it will gradually increase your users and then back it off and equalize itself out to tell you your system is capable under its current configuration to handle 50,000 users simultaneously. So just kind of a cool way to reduce the amount of toil that's there in doing performance testing. But first you have to know what's happening, then you have to be able to produce a production-like workload, and then at that point, then you're kind of ready for this resiliency journey of like, let's get into resiliency testing and understanding our workflows there and things like that. So just kind of wanted to put that background, and then we can, maybe dive into the architecture here for a second.
Yeah.
So what we're looking at here is actually a series of different solutions that Vertical Relevance has kind of developed to help us go on this journey, right? You're actually the bottom one here you're going to see is that intelligent capacity evaluator. That's that performance testing piece that we've kind of built to help people in that journey. The reason why we actually need it is because to do any kind of resiliency testing, you have to have a production-like workload. Because how can you validate data loss unless there's actually data to validate?
Of course.
Right? So it kind of makes sense. But you'd be surprised how often that people don't do that. So we want to tie that in as part of this overall framework. But what we find is the challenge here is, I'll say, there is an execution piece. We're going to talk about that. But what we want to talk about is the challenge is how you identify the test cases that you need. What's your test case library? And then how do you execute that test case library in a way that has the proper coverage for your applications? And then ultimately, this last piece here is how do you then report on it, right? How do you report kind of the resiliency strategy on what's happening? So that's kind of what you're looking at. You have your library, your execution, and then your reporting capability. But we have this one box right here in the middle, this experiment generator. So we're going to hopefully by the end of the session, you'll kind of know what these are. And we're actually going to go through and we're going to code up pieces of all of this today.
Hey, Austin, I heard that last one. Is that something that's just coming out? Or
It just came out. Thank you, Jay.
I hear experiment generator.
yeah.
What is that? It sounds like it's on all the newsreels, right? Everybody's heard about it at this point. VR just yesterday released on our website the experiment generator solution. So we're constantly adding new things to this. This is a really, really cool one that we've built. We've implemented it at a couple of places, and so anyway, just you can see the link there, right? Click on it. Hopefully, check out our great work. That we just published that yesterday. We're really proud of kind of what it does here. Thanks, James.
Yeah.
So, one of the things that we want to talk about that is kind of required in this framework is that you have hundreds of application teams, but not all of them really fully understand resiliency. Right. And if you went out and you told your one application team to go and, hey, you have to do resiliency testing, it would be probably challenging for them to get the right level of coverage and depth of expertise that you need. But if you told a resiliency enterprise team that you need to go and do, go and test this particular application, it's going to be really hard for them to understand the nuances of the application to accurately test it for the outcomes that they need. Right. They don't know what the RTO and RPO are. They don't know how to validate the data, what queries need to be made to the database, things like that, right? So somehow you have to combine the expertise from like a core centralized resiliency team and an application team to really give you an effective resiliency solution. And so that's where we kind of get these two pieces where you have a FMEA, a test case library, you have the coded up activities on how you actually introduce and do resiliency testing. But how do you combine both of those to have an accurate application-specific, right, implementation of this? So you have something that's very enterprise generic. How do you make it application-specific, right? We're going back to that kind of design principle. And that's where we get this experiment generator. And what the experiment generator does is it allows you to actually pass in a test name, and it will actually parse the name, and it will automatically identify all the components that you need and auto-generate a test for you to run without you having to touch anything.
Wow. Okay.
So the problem was like when we started off with one of our customers, we identified like 1 to 200 resiliency tests that needed to be executed against their environment. And then we got deeper, and I'll show you why it scales so badly in a second. We'll change screens here. But I think we're now at the point of like 2,000 or 3,000 test cases for this one application. And you just can't handle that with like a library of YAML files.
Yeah.
As a developer, can you imagine like the nightmare it would be to like change one function on all of them or something? So we decided, okay, we're gonna handle that scale problem, and we're gonna handle that disparate teams problem at the same time, and we're gonna create automatically experiments or test cases on the run. Right at runtime, you click it, and it just generates all 1,000 test cases and executes them for you. And that's kind of what's cool here about experiment generator. So we'll kind of show you what that looks like when we go through and code up here in our demo in a minute. So, the experiment generator creates your experiments, and then your execution framework actually goes through and will execute those against your application and determine whether or not you met your NFRs, right? What was your downtime? What was your data loss? All of that. So any kind of questions so far on this? Like we'll probably pull the screen down, James, unless you have anything specific on the architecture here.
There's nothing in the chat right now, but yeah, just the idea of like you were saying, just being able to generate all those different like test cases on the fly like that. That's huge. Like that's definitely something that is going to help for sure. Like with did you say like all you have to do is give it like
we're going to call it a test name, a test case name, or a test scenario?
Yeah, and then it'll generate it from that. That's great.
So let me kind of show you what that looks like. So we're going to start off by showing you how you identify your test cases in kind of some meaningful way. Okay. Actually, I'm going to have to reshare here to get it.
Yeah, that's great. That's cool. And while we're doing that, if you're just tuning in, welcome to Howdy Partner, our AWS live streaming show where we bring partners on. Today we have Vertical Relevance, and we're doing deep dives into their products. Some of them Experiment Generator, Experiment Broker, and we're going into Resiliency. Because if you're not resilient, it ain't working.
That's right. All right.
Cool.
Can you see this? Yeah. So this is just like I Googled, I think 10 minutes before we started, architecture diagrams, and I just found this. Okay. So this is like some generic on the internet architecture diagram with EKS. And you just look at it, it's got your typical things. You got like an ALB sitting on the front of it. You got some Kubernetes workers for EKS with some different pods and nodes. Maybe this is not EKS. I guess this could just, it looks like they're doing some Fargate stuff, right? You got some, an ALB ingress controller, some Fluent bit type work that's kind of happening here in the control plane, right? So these different AWS services. And so people will look at this and they'll be like, okay, how do I translate that into knowing what kinds of failures I'm looking at? And probably the one that everybody always immediately gets is like, well, I could start killing some of these pods and some of these worker nodes, right? Termination crash, pretty easy. Like that's what everybody automatically assumes. What we are going to show you, though, is ideally what we call the failure mode effect and analysis framework. It's FMEA. You can actually do some research on it. It was originally developed by the government to help them do testing on their different defense systems. So, as they were trying to do testing on, and like this is not software, this was hardware. Like this is, they're trying to do different testing on the different products that they were creating for the government. They had to have some way to make sure that these things were reliable. And so they use this framework, and it's basically been translated and now used kind of broadly in the industry. We're seeing it more and more into different engagements, right, as they're getting in there. So basically the way that it works, and again, I gotta zoom in here.
Okay.
What you do is you start by identifying a set of test categories. And these categories are going to range, we're actually just going to look at the top 5 for now. So state, resource, network, just general broad level categories. Against each of these categories, you're going to start to identify different failure events that could potentially happen, and whether or not you want to make them in scope. So graceful shutdown, reboot, and termination crash are the 3 for state that we've identified. For resource, we have quite a few more though: high network, high CPU, high I/O, high memory utilization, root volume exhaustion, right? All of these different kinds of failures. Because here's what you have to understand is that failures happen at varying degrees and varying different ways. And making sure that you're covering for all these different failure types really becomes essential. So in all, we have about 30 different failure types that we've identified across these 5 different categories, right? Or these 5 different test categories to produce for us, right, generic failure events that can be applied onto any kind of architecture.
Okay. I'm getting it now. Awesome. So like we can pick, and we can pick and choose like which ones of these are. I mean, I'm sure you'll get there, but like we can do all of them. We can just do one of them. Like we can pretend that everything's great and just test a graceful shutdown, or we can just pretend like the world's ending and just go through everything.
Nuke everything if you want to. Yeah. So the idea is that depending on the service, you have access to do these things. EKS is such a great one because you have access to the OS of the node and the pod that's running, so you can introduce a lot of these failures. Some of them though, just don't make sense. Like if you're running an MSK cluster for Kafka on AWS, AWS doesn't give you access to the instance that MSK cluster is running on. I can't go and introduce, packet loss, unfortunately, on AWS's, managed EC2 instance that they're doing for MSK. So some of them you have to reduce. The more managed the service, the fewer events you're able to actually introduce, but we still will introduce as much as we can.
So, Austin, say I'm a customer and I don't know which ones are important, which ones are not important. How would I go about that? Do you have, do you provide support there on knowing which ones are more important based on my application?
Absolutely, right. We will prioritize these with our customers. We've done that actually a lot of times where we sit down and be like, hey, you know what, by the way, you should start with, these 5. A lot of times you create what we're going to call a resiliency maturity model. And you could think about it as, like a level 0 or level 1, all they really implemented is termination crash. And then a level 1, the next level up, we introduce the next 5 or 6 that we feel like are critical. I'll say probably in this list, a lot of times configuration we actually put at a later phase, because if you're doing everything by pipeline and in a really well automated CI/CD pattern, you should ideally catch that an IAM role was removed, or that you have a certificate expiration. Like ideally, your CI/CD pipelines catch a lot of those details before it ever gets pushed to production. So we sometimes deprioritize these in favor of these other more types of failures that are a little out of control of the people who are managing the systems.
In Austin, many times we get Jerry, James, we get brought in to do a resiliency assessment. So we'll identify what's important, what's critical at that juncture, right? So that prioritization will come out of that assessment.
Got it.
Exactly. And if you have like a customer, like let's take the one where I was saying, 250 milliseconds per transaction. Performance is clearly critical for them. So we had to packet loss, network latency, top of the list, right? Made a lot of sense that you had to test those because those ones affect your latency really well. You have other applications that are much less performant, then maybe you don't quite care as much about what 2% packet loss could do to your system. If that kind of makes sense.
Yeah.
So you take those failure events, and then what you start to do is you start to define these different components of your system. I'm actually going to go to a different tab here. And you start to produce scenarios. So you could start taking some kind of target application, and then you start to identify the different components of that application and the subcomponents. And the reason why you have to do this is because you can't just say EKS. EKS is full of so many different sub and subcomponents that you really need to drive down to where you want to introduce that failure to get very, very systematic. So if I go to this, for example, I can't just kill the worker node. I have to kill the pods on the worker node as well. Those are 2 different kinds of failures, and your system might respond in 2 very different kinds of ways, right? So we start to identify, and I'll give some examples here. If we were to do, we have just hundreds of these things. Let's say we actually did some outpost work, so kind of the same thing for outposts, but there's some EKS stuff here that I'll get to. So, let's say you had Jenkins that was running on top of EKS with worker nodes. You want to do some worker node testing where you're going to kill the EBS volumes and the different EC2 instances in kind of different ways for that Jenkins controller. Then you might have an ingress controller as part of it as well, right? You have the Jenkins agent, which is also part of that, right? That all kind of run off that. So it helps you drill down to be very, very specific on where you're targeting those specific failure types. So you can get down to Jenkins, Kubernetes, worker node, Jenkins agent, EC2, resource, high IO utilization. You know exactly what you're doing and where you're going to do it. And so then that lets you then drive into scenario names. So now here I have, a list of scenarios against my application. And this is all genericized, right? We don't have any customer data here, obviously.
Yeah.
But lets me get to very specifically know exactly how I should introduce my failures, right? What that resiliency testing looks like. Any kind of questions about kind of for me and kind of does it make sense that depth of knowledge and expertise you kind of have to drive?
Yeah. My question for this was say I'm not an expert in all these kind of things. You said you do resiliency assessments. Is there, instead of having to do all of my own, is a lot of this like packaged in, or they're like, how do I say it, like pre-baked or pre-made, like kind of things?
So why don't you go ahead and, yeah, you can stop sharing the screen for a second, actually, James. Yeah. So the way we would say that, describe that as like, yeah, we bring all of these as things that we give to our customers.
Got it.
So we can bring them like this FMIA spreadsheet, and there's a lot of work, there's a lot of automation that we've added into the spreadsheet and things like that to make sure that it all ties together nicely, there's not drift and things. But a lot of times what actually will happen is like a customer will say, hey, come in, we want you to look at our architecture, we're trying to decide what to do. We look at the architecture, we examine the architecture diagram, and at the same time we're building out the FMIA, and we kind of deliver both of them to them. Here's what your architecture should look like. You want it with your given non-functional requirements, you should go active. We've done this architecture diagram. We'll even do something called a resiliency architecture readiness assessment. It stands for RA2. It's something that VR and AWS ProServe actually co-created a couple years ago. So we'll do this whole assessment as part of it, and the outcomes of it are usually architecture diagram, key things that they need to fix, as well as a fully filled out FMIA spreadsheet to help them kind of get on their way, and gives them that strategy that they can then disseminate broadly across the organization.
Okay. I'm trying to find I'm trying to find the RE2, and I'm just getting Resident Evil right now. So I'm trying to find some links to that.
I don't know if we have any. I don't know if they have many links like for public, public consumption of it. It's not. But anyway, it's something that AWS and the GFS ProServe team, which is the Global Financial Services ProServe team, has created with Vertical Relevance, to take their customers and do these assessments.
Yeah, I was going to say, because it did sound familiar. That's why I perked my ear up. So I was like, whenever something perks my ear up, I start looking for it so I can try and link it in. So
yeah, for sure. So that's where we get that scenario name, right? And that scenario name is going to feed into that generator. The generator is going to parse it, and create the experiment. So actually, what we'll go ahead and do, let's go ahead. Let's just do this right now. So like let's toss it back up. On our local here, right, in our AWS environment at VR, we have an ECS cluster that's running, and it has for an application called Pinecone. Okay, now you can put this up, but I'll just kind of delete this here. Kind of see this. So we have this new Pinecone application, right? That's the name of the application that we're testing here. It's running on top of an ECS architecture, right? Part of that ECS, you have a service, so there is a service name that's associated with that. It was all created using CDK, and CDK does funky things with service names and task names. So I'm not going to paste that service name in here because it would just look awful. But let's say it was there, and then let's say I want to do task, or maybe this is the actual, this is the actual service of the container, right? The container service that's running on it. What we're going to do today is we'll take this as an example. So like, let's say we have, container name, or, container image. And we're going to do application, and we're going to say type fallback. Okay. And what we mean by fallback in this scenario is like, what happens if you deploy bad code? Someone deploys a bad container. Do you have an automated rollback scenario, right? On what happens there? So, I'm able to go over and I'm able to say, hey, here's my scenario. I'm going to put it in scope. A lot of times what we'll do is when you create the FMIA, you create a very exhaustive list, and then you start pulling things out of scope that make sense for the application, review it with the customer, get some kind of prioritized set going forward, right? But, like, let's say this is the new scenario that we actually want to kind of start to create. We know we need to go automate this, right? This application fallback for an ECS service, because previously everything was done with EKS, and how you deploy containers to EKS is very different than how you do it to ECS. So I need to stop sharing so I can actually start sharing some code here.
Okay. Yeah, sounds good. Let's dive in. I like code. Let's code it up.
Let's do some code. Okay. So the first thing I'm going to do is we're going to go over to. Sorry, I got to share screen. I might share my entire window this time.
Yeah, just share what you need to share, and then let me know when it's ready, and I can.
Yeah, we're ready to go.
Okay.
This way, I'm going to go back and forth between a couple of things here, so we'll just do this.
Okay.
So what we have here, this is the experiment generator. In order for it to generate the experiments, the code that you actually have to run. You have to be able to understand things about your application in order to be able to execute your target, right? Like, what's the container name? What's the cluster name that I'm using here, right? There has to be configuration about the application to be onboarded into the framework. Just think about it, all the detail, all the inputs to all the functions for introducing failure and validating my results. That's essentially what your configuration is. So we have here, through an API system, right, using API Gateway and DynamoDB, we store these configurations for these applications. So if I wanted to go through, we're going to create a new template here. So before, maybe we had, a vertical broker as one of our applications, and we started with this here. I'm going to actually start to go through, and I'm going to show you how we do this mapping in order for the generator to be able to parse the scenario and produce for us all of the code. Okay. So I kind of had this pre-created a little bit just to kind of help us out, but you can kind of see where you have like first the scenario method. We know we need to introduce, right? So we know that the application name is Pinecone. So there comes the Pinecone from that scenario name. Okay. ECS service task. And rather than task, I think we said container image, right? Let's actually make sure that we have, I think I capitalized container and image. And did I capitalize service? I did. And application fallback. So, right, we kind of have this is like defining, that this is the scenario that we want to run. Anytime we see, regardless of the application, it doesn't matter about the application, when we see ECS service container image application fallback, I know I'm going to need to do a set number of actions, okay? And the actions is where Chaos Toolkit comes into play. And this is Experiment Broker. Experiment Broker is kind of a wrapper for customization that we do for chaos testing. So this is where we would define, for this given kind of scenario, I know that I need to do a set number of actions and probes, right? Things I want to change the environment, validations I want to know about the environment. And then I can come in here and, actually we're going to go code this up first. So that's the first piece that we need to do. So we need to go code up what this action looks like, okay? So we get into actual Experiment Broker, okay, our Experiment Broker module. And underneath our experiment code, we have Experiment VR with all of the different services that we're kind of supporting doing actions here. You guys following along, by the way? James, any questions?
Yeah, I'm following along.
Just to like interrupt me immediately, right?
Yeah. I'm just putting my silly little comments in there.
No, you're fine. All right. So, AZ, CloudWatch, DynamoDB, we created a new one today just for this for actions. All right. So I'm going to have some actions here. And, first thing I know, obviously, we're going to need Boto3 for this. So I'll import Boto3 at the top. And then I know that we're going to need to do some kind of piece. And we have kind of a format that we, actually not always, so let's just say, VR def, sorry, VR update ECS image. Let me say, yeah, image. Okay. And let me see here.
And just for anyone out there in chat who doesn't know, Boto3 is the AWS SDK. It's how you can interact with some of your services and resources.
Yeah, absolutely. We're big fans of it here.
Yeah, it's nice. It's nice to be able to, instead of dig through the console or, stuff like that, you can just interact through code. So,
absolutely. So the first piece here, we're going to need to actually create our client, right? So ECS client equals Boto3 client. You're going to find that I am ECS. We'll toss in a region here, okay? Because this could run in multiple regions. So I know immediately that I need to pass in a region, right? Part of what I'm doing here, because this could be run anywhere. And then let's say we know that we need to do this off a cluster, so we're going to add in a cluster name. And then usually what you typically do is you have a different service, right? So you have like the Pinecone service that's running on it. So I know we're going to need like some kind of service name as well. And then from there, we should be able to, let's see, get a response from ECS client. We're gonna describe the services because we need to pull out the task definition. And I'm not sure how familiar you are with ECS, but you have different services. Those services instantiate tasks. And so if you want to change the cluster image, that is from a task definition that the service uses to spin up a new task, right? So we'll take the service name and we'll use that to kind of help us spin up the task. So we're going to say ECS client dot, I think it's described services here. And I might think I'm going to be fine here, but Bodo 3 ECS described service. So we're going to need to pass in the cluster name essentially. I think that's the only one that's actually required. And maybe some services. Yeah, and the service name, right? The service name that we want. So you can pass in the cluster and the service name. So cluster equals cluster name, and the services, and is that it's an array. So services equals an array, and we'll just pass in that service name. Right? Okay. Pretty simple. And then we need to pull out the task definition, right? From that, let's look here. Luckily, I've done a little bit of my homework on this. But you're able to pull out the task definition from one of the responses here. I believe it's actually at the root level. When you do that, actually, no, you go services, and then you just get the task definition, and it'll return that to you. So we'll just do that. So the task definition name is equal to response, and then we get services 0, and task definition.
I got to start coding more.
I know, right? Yeah. And then the response from that, what we then want to do is, and I probably actually would have said this is like the service response or something.
Yeah.
Service response, right? And service response. We then have to define that task based off of that name. Because when this returns the task definition, it just returns the name of that. So the task response, right, is going to be equal to the ECS client dot describe task definition. You okay if I keep using Bodo 3's documentation here?
No, that's great. The documentation for Bodo is pretty strong. So
it's pretty good. I've always been a fan. Describe task definition. Oh, not easy. Bodo 3. Nothing like getting the CLI for it when you want the Bodo for it.
We just cursed ourselves.
Exactly. So yeah, you just pass in the task definition name, right? You pass in what's called the family and the revision. This is basically the name and then the revision. I think if you don't pass in the revision, it always returns the latest.
Yeah, I think it defaults to the latest.
To the latest. So you just say, describe definition name. Now, what's interesting is, while I'm kind of coding this up here, and then task, sorry, I should have task definition is equal to, and then I think the response, hang on. Yeah, is equal to this task definition name. That's right. So I get the task response. That gives me back the task response, right? And then I can say task definition is equal to task response task definition. Now I have that definition. Go ahead.
I think we might have glossed over this just a little bit. So this repo that you're coding in right now, that's the one that we posted, right? The experiment broker repo.
That's exactly right. Yeah.
Okay, that's what that was like. So we pull that down first, and then we start.
pull this down first. Yeah, I
Yeah.
probably should have actually done the whole process of like giving me a clean slate, right? Clean environment.
Oh no, that's okay. I just wanted to be sure. I was like, I was just looking to the left for a second. I was like, wait a second, we didn't code that much, you know.
Yeah, no.
But yeah, I dropped that into the chat. And that's open. Is that open source?
Yeah, that's
I
everything
think
that's
so.
on our that's public on our GitHub repo is
Got it.
you know, people can kind of consume here. So
Yeah.
you know, what you'll probably find in the public, you won't see as many services covered here.
Yeah.
Right. The whole framework and how this framework all works is all there for people to look at and use.
Awesome. Cool. Okay. Sorry.
No, it's okay. So you know, essentially we're getting that task definition, and then the last piece, you know, we need to do is we actually need to update it and then push it back, right? This part got a little long. I'm gonna actually just copy it. Like most of this I've just been doing, but I'm actually gonna kind of copy and paste a piece of this in here, if that's all right.
Yeah.
So like we're gonna get, you know, so we want to update some containers that we know with this, right? Especially if you have kind of more than one with that name. So, you know, updated containers, and then for your containers inside of your task definition here, right? If the name is equal to, and then here's your container name. So we know that we need a cluster name, a service name, and then a container name, right? So that's kind of one of the pieces. You know that you need to kind of change whatever that container name is. Change that here. Oh, wrong container name. And then we also know that we need a new image, right? So the image URI.
Yeah. Okay.
And so that is going to be, you know, if the container name is the container name that we want, then we're going to update the image of that to be the URI that we need, right? So point to the version. Ideally, what this means is that, like, in order for this service to work, to do this failure, right, where we're going to be deploying bad code, you actually have to go to your development team and say, hey, I want you to create for me a container that will fail.
And then 50 people raise their hands and are like, I'm all right, it's already done. I did that this morning.
Yeah, exactly. Like, it's really easy for them to give you an image.
Yeah.
That works, right?
Which one do you want, boss?
Exactly. Which one? And, you know, we'll be kind of like, well, it depends on how you want it to fail, right? And you
actually, they know that's true. Yeah. How do you want it to fail? Yeah.
Yeah. In the case that we're going to talk about here, typically the failure that we talk about is just like, hey, we just want something that's going to fail the health check, right? So if ECS has a health check, we just want that to fail. So like maybe it doesn't even start up, right? Maybe it was so badly broken the container doesn't work. But there are other ones where like you have a certificate expiration.
Yeah.
Right? So you create an image that has a broken certificate. Or you could do one that you want to do like a circuit breaker, right? And so you have code that you know will trigger some kind of circuit breaker to occur. So usually you'll actually have like a series of images that are just designated for resiliency that you kind of pass in, and you can pass in the right image URI that's based upon that resiliency, based upon the failure type that you're trying to introduce. I hope that kind of makes sense.
Yeah, no, absolutely. Yeah. And like I said, I was joking around, but then you pointed out, yeah, you have to pick the way you want stuff to break. Yeah.
There's a lot. So then you get a response, right? So you update your updated containers, and then what you do is you start to build a task definition. So, you know, you have your task definition, you pass it in with the family, you know, the task role ARN, the execution role ARN, right? Network mode. You pull all those things from the existing task definition. You don't have to rewrite those at all, right? So I've already pulled, that's one of the reasons you pulled the existing task definition. It's funny enough, Bodo 3 doesn't give a way to basically just update single values. You actually have to create a whole new one and then upload it to the family. So that's why you kind of pull these values out, and then you toss in the containers, right? The container definitions that have been updated that you want to do. And then you can give yourself, you know, a new task definition arm is equal to response, right? Because like you've actually gotten the response here, so you can actually pull up the task definition arm if you want to. And then you push that. You get the service stuff data. So we're going to say response. Oh, no. What am I doing? Task definition. And it's task definition ARN, right? And then you can do this last piece, which is let's get another response here. ECS client. Update service. We actually want to update the service with this new task definition. So when we push it, it pushes that new bad code. Okay.
Okay.
Cluster name equals cluster name. and the service equals the service name. Luckily, we already have all those. And then the task definition is equal to the task definition arg. And there we have it, right? And at that point, we can return the response and we're done. So at this point, we have an action now that will introduce a bad code. And actually, rather than doing update ECS image, right, we probably would actually kind of wrap this. Like we probably have one def, VR update ECS image, and we have another one that says def VR, application fallback. That kind of makes sense.
Okay. So like when it does break, what it's gonna go, like what we're gonna go back to, basically.
Yeah, exactly. Like so,
Okay.
when this is what we'll actually refer to, because that way I can do different variations of this if I want to with my different kind of values. We won't worry about it now. But you can see how this would actually be like a shared service. And if you look at like EC2, for example, we have a shared folder and actions. Actions are the things that actually get referenced, and shared are all of those kind of shared functions. So I probably would have put this in like a shared folder that updates any image no matter what. And then I have one specifically that will call out here, rather than container image, or like rather than container name and image URI, I would say fallback image URI.
Okay.
Does that make sense? And then I just pass it here.
Yeah, that makes sense. My question was, with the Pinecone FAMIA experiment generator stuff, where exactly or how are we bringing that in? Like with the the thing. Okay.
Yeah, that perfect segue on that.
Look at that. That wasn't even planned, folks. Like
I know. So we're gonna come back here to the experiment config. So I have the scenario method, right? And so now I have Pinecone, right? With the scenario method, I know that I need to do some kind of like I need to run that scenario. So I believe it's just you just basically can put like a list of those scenarios. And let me just see, I'm trying to get the exact thing right here. So like, this one is experiment VR load actions. It just basically points to what we're doing there. So I'd say experiment load, it's not load, we're gonna go ECS actions, and we are gonna say, let's get the name there, VR update ECS image.
Okay. Oh, okay.
So that kind of makes sense?
Yeah.
And ideally what this means though is like right before this, if we talked about how you always have to introduce a load onto your applications. Well, here's how I generate a load, right? I have another one for this. So now I'm generating a load. And this is all just defined for this kind of generic infrastructure and failure type, right? I don't care about Pinecone yet because Pinecone is what like I'm going to do my NFR definitions on. So, I'll talk about that in just one second. But we basically start to define, hey, for this generic scenario method, I'm going to start identifying the different functions that need to happen, right, for that thing. So then, we take a look at, okay, the scenario configuration. So for this scenario configuration, ECS container image application fallback, right? I have that here. I then need to actually just define those different inputs, right? And kind of what I want those values to be. But the cool thing is that if I already have them defined as part of an application or as part of another configuration, I don't need to redefine them. I don't need to define region multiple times, right? Region can just be defined once on this piece. So this is meant to just be generic. So like, even though you might have like, I think we have, 150 different actions and probes that have been identified. I don't need 150 different mapping sections. I just need the set value of all those configuration items listed here inside of my experiment generator. Does that make sense?
I think so. Say that again. Like I know we don't want all of them, but what kind of say that again?
So like pretty much every action is going to require a region.
Oh,
right?
Okay. Yeah, the mappings. Okay, that
the
makes
mappings.
Sense.
What this does, this just maps all of my. These things are going to require inputs.
Yeah. Okay.
And we want to just take the set of inputs. We don't want to take a duplicated set, right? We just want the deduplicated set of all of the configurations that are required. And so right now we're just, we supply those here inside the scenario configuration. And then it allows you to override them. So for the application, I can specify, certain things that are generic to the application. My application is running in this region. But if I wanted to override it, I could override it with something else here for some given reason, right? So you could say, actually, I want this one to do in West 2, right? So the idea is to kind of allow people who are doing this to kind of modify these inputs to those actions that we created. So you kind of have your top level here, right? For Pinecone, I have a container name. I have a container image that I want to push, right? I probably actually call this my fallback image, right? My fallback container image. And I think we actually call it, did we call it container URI? So this is where I actually have to get this list here. And I would make sure that this list is represented here for my application. So cluster name I need a service name, right?
Yeah.
And I specify what that is. I have my image URI, which I'm going to put here. And then my region and container name, right? There's one more. But my container name, if the set there is Pinecone, right? I just put Pinecone here. The service name I can get from AWS on ECS.
Hey, Austin.
Yeah, I don't have to go.
Geo19 wants to know where the actions and the probes defined.
Where the actions and the probes defined. So
yeah,
the actions and the probes are all inside of Experiment Broker. So the actual execution framework, right? So if you were to, let's say this, if you wanted to execute a test, that's where the actions and the probes are defined, right? You define them here. If you want to generate these into actual, to combine them into a test case, actually, that's a great question. Let me show you what an experiment starts to look like. Right? This is what experiment generator is going to produce. Maybe this will help. Okay. So you have, a configuration. These are the inputs to your arguments that you want to pass in, right? You have an action. You want to establish a load of 1,000 transactions a second. Another action, you're going to crash an ingress controller. You're going to have a probe that's going to alert that the ingress controller is terminated, right? You want some kind of probe. We commented out for now, right? And then maybe you want to run this twice, once at 1,000 and once at 10,000 transactions with different actions and probes, right? Do you see how this is what an experiment starts to look like with all this YAML?
Yeah. Okay. Yeah. I don't think we really touched on probes much. Is that a VR thing? I'm not familiar with it.
Probe is a chaos toolkit thing.
Okay.
And it's basically, think about it as validations. What do you want to see happen as a result of your test?
Okay.
Okay. Do I want to check that all my pods are healthy after my test is conducted? Let's say you go and you start killing pods as part of your test. But you want to, what you're really testing is ECS's, pod rebuild service happening in the time frame that I want it to happen in?
Okay.
Right? At the end of the test, do I still have all healthy pods? Is everything rebuilt? So that's a probe. Or it could be, we also have custom probes that say, what was my RTO for this time frame? Did I have downtime? Did I have data loss? We'll actually go a lot of times and query databases with our probes and say, I dropped 1 million transactions for my load generator. How many actually made it to the database? And can do some analysis and say, hey, by the way, you actually did have some data loss.
Okay. So would it be fair to say that it's similar to an assertion in a test case kind of thing?
That's exactly it. It's an assertion.
Okay.
Actions are things that you do, and probes are things that you observe.
Okay, cool.
And so, it's a combination of actions and probes that give you these experiments. And this is why I was saying, we used to have to create and would have hundreds of these YAML files sitting there.
Yeah. Yeah.
If you wanted to change one, you had to go and change. Like if you wanted to change your load action for any reason, you needed to add an extra argument, or you wanted to whatever, you had to go and change it in all of your experiments. It was kind of it was a real pain, to be honest. So what you do is once you've created the actual action here, you go and you create the corresponding configuration for the application itself. Right? This application, I know that if I want to do that kind of failure, I know that I need to have a service name, a container name, a cluster name, an image URI, right? I have to have all these details here. And then what you actually do is and actually if we save this here, so we save this ECS image, right? This is what we're going to get into some of the bit of magic that kind of happens with all this. And if people have questions, please keep shouting them out.
Yeah.
So I'm actually, normally we would do this in pipeline, but I'm going to do this. I'm going to do this a little bit of a funky way here, just because, so people can kind of see how this works. So I need to go to, actually, I think I can just go here, and I can say experiment VR, and I want to do reveal and finder, and I'm going to compress it. Okay, and then what I can do is, actually, I think I'm going to do one level higher just to make it easier for me on my thing here. Let's try that one more time. Experiment code, reveal and finder, compress. So I'm actually going to take this code base, this Chaos Toolkit Experiment Broker code base, okay? And I'm going to upload it into Experiment Generator.
Okay.
And the reason why I do that is because Experiment Generator is going to scan through all of these actions and all of these probes. And it's going to auto-generate all of the YAML snippets from this. So I don't have to go and create YAML snippets and it just like copies and pastes them. What it does is it'll actually look at the definition for all of these actions with these values, and it will create, right? It'll create this YAML snippet for all of the actions and probes that I have defined.
Okay.
So it scans your code base and it does that for you. And then you establish the mapping here of what matters, right, for your application.
Oh, okay.
And then when you produce a scenario, it auto-generates the experiment. I hope that kind of makes sense. So the way that I would do that is I would just, I need to get this a second. So where am I at?
Let me, Jessica posted the Chaos Toolkits framework earlier too. That's also open source, so if people want to contribute to it or just pull it down, go ahead, feel free.
All right, let me just get into my environment here. Source, maybe, no, Twitch. I've been just getting into my Python virtual environment.
Yeah.
And then we're going to back out of file here, and I'm going to basically run this. Just trying to get it so it's simple here for everybody, so I'm not spending all my time doing crazy stuff.
Oh no, it's all good.
People like crazy stuff?
No, just I can. Yeah. While you're pulling that down, if for everyone, for all our viewers, if you can take AWS, I always say this every week. We're famous for our surveys here. We love our surveys. If you can take 30 seconds, let us know what you liked on the show. Let us know how you're enjoying it. If you want to connect with VR, go ahead and leave your email address. I could pass it on to them for sure. Connect with VR also on LinkedIn and their websites as well. But please take a couple seconds to fill out our survey. It's like 3 buttons. So thank you. That would be great.
Awesome. Love to hear any feedback on this for sure from everybody. So, we're going to take this Python, we're going to take this generator tool, we're going to upload that experiment broker code, right? Those new actions and probes. We're going to compress that and we're going to upload that up to experiment generator so that it now can do that kind of scanning. And hopefully I don't have to have you stop sharing screen and redo my credentials. We're good. Okay. And then from there, we need to, right, we come here, I was going to get the service name. So here's the service name. Again, like I said, it's, due to.
Well, I'm excited. Now we actually get to we're going to actually see stuff. Like
Yeah.
CC, like pictures, pretty fun stuff.
So we get to, we define these items here, right, for the application. Container name. I'll just put these in here as null just to make sure that, you could override all of these if you want to. We let people do that if they want to. So cluster name, container name, service name, and it was important that we felt like people could be able to customize this as much as they needed to as we were going through it. And then the region. So, we have those values there. Do I have the image URI? So image URI,
yeah.
Container name. Do I have actual container name? I think that's fine.
So
yeah, go ahead.
Is the documentation for this, is it in the repo itself or on the website?
It's on our website.
Okay.
So I think we posted the experiment generator, right? And there's what's called a playbook that's part of that.
Okay.
That's on the website there.
Yeah. Because it's awesome, but if I don't know where to start, then
it's a little tricky.
A little intimidating.
Yeah. There's a lot here. And that's why, we want people to reach out to us, right? So we have those values. There is also this concept of a steady state. This is where the application, again, can define what their steady state is and actually gets included as part of that experiment. So if you look at an experiment starts off by saying, am I steady? Is my environment up and running? It then adds a load. It then adds a failure. It then validates your infrastructure response and validates your application response, right? So did my pod roll back when I deployed bad code? And then the second piece is, did I have any data loss or downtime during that process? Right? So that kind of gets you those 5 pieces. So the pieces that you need to get from your application are going to be your steady state, your load generation. Do I know how to introduce a load? And then do I know how to validate my RTO, my RPO, right? Some of those different things. So, you probably actually you could add those into your steady state, or, you have those different probes and you would add them here. So, if I had some specifically for Pinecone, I would say experiment VR, but it would be a probe and it would be validate Pinecone RTO, right? That's as one of those values. We would just toss that on at the end for these different values. That doesn't have to go on to you could add that for this specific scenario if it was scenario specific, but we could also add it down here into the application config as saying, hey, I want all of my test cases to run these probes at the end, and experiment generator will do that for you, right? Okay. And toss it on the end. I'm not going to have it right now just because I don't have those probes created. So we get there, and then the next piece is to actually, we have to commit this. So git status, git add, I think it's just templates Pinecone. So templates Pinecone.
I gotta ask, where did the Pinecone name come from? Is that an actual thing? Is that generic?
We actually have a service. Yeah, we actually have an AI tool that we built internally, and it's called Pinecone.
Okay, cool.
We've been doing a lot with AI recently.
Get that on the next show, shall we?
Yeah. We got some fun internal AI stuff. So anyway, we just needed an ECS environment that I could test against. So we just liked the name Pinecone and decided to take it.
Yeah. Okay.
Hit commit, and then I'm going to say added Pinecone YAML config git and then git push. So this will the remote contains work that you do not have to get poll first. Oh man, rats! Of course, I would have Git problems for this thing, right?
Lovely Git problems.
Oh man.
Here's where all the viewers come out of the woodwork to start teaching you how to use Git.
Austin's doing his own chaos testing.
There's an XKCD for that, by the way. Okay, let me see. Git status. What are these things? The problem? You have 1 and 2 different commits each, respectively. Git pull to merge the remote branch into yours, and just not staged for commit. Untracked. So should I do a git stash maybe? Get rid of those, and then git status, and then git pull. No, rats.
Let's say you have divergent branches.
It's what it looks like, and you just specify how to reconcile them. You can. Should I go here?
I did just run a git config rebase, but that was for my situation. So,
So that helps me a lot. Wow, look at the changes on this thing. That's not disconcerting.
You didn't realize you did that much work today?
No, I think I imported requests, the request library recently, and I think maybe it's trying to like push those as part of it too or something. I'm not sure.
Okay.
You guys should do a rebase. Git config. No. You have divergent branches, and so you can do so by running one of the following commands sometime before your next poll. Rebase false. Should I try that? Fast forward.
Yeah, I did just run that command yesterday, and it fixed my issue. So
it worked. All right, we'll try it out. Okay. Oh my goodness! Look at that.
Fantastic.
Look at that. Jerry coming through.
Now I just got to fix my problems here.
What do we got?
I want that's wait, that's good. That's staged. Where's my? Oh, this is just merge. Finished. Okay. Git push. Hey.
All right.
Thank you. All right. So anyway, that's going to run. What that's going to do is that's going to push up this new definition, right? So it's going to take. Oh, wrong one. It's going to take the this pine cone and it's going to push it up and get it onto that cluster. So we can see all of it. I could have done it through a CLI command as well to just push up the configs that we want for pine cone. We just did it through GitOps instead. So anyway, that'll push up. And then we can, what it should do is we can then supply it once it's up there, and I'll double check that real fast.
Oh, I just thought of something actually. Where is this running? Like not cone, but like where is? Huh?
It's all on AWS. Is that what you mean?
I mean, it's all in a. Is it on ECS or?
Yeah. So if we go back to here.
Okay. Yeah. This is. I'm glad you pulled this up. Yeah.
Yeah. So we have so we just did all of our changes here in the code base, right?
Got it.
That's what we spent all this time. We then push, and we made changes here to this code base is here and this is here. Anyway, so we made changes to the code base and we pushed them up. And so Experiment Generator knows about this code, right? That was that first thing where we uploaded the zip. And then we made the configuration change, which pushes them to Dynamo. And it's all fronted by API Gateway with a Lambda function that kind of sits on it. It's going to, what we're then going to produce is once this is done with that new config, we're actually going to push it we're going to push it a scenario name. The scenario name is then going to push the actual YAML experiment into an S3 bucket. And then our chaos toolkit can reference that S3 bucket directly and do our actual resiliency test.
Okay. That pretty much answered my question. Yeah.
Yeah. Yep, we're good there. I think it's done on that. Check this one. Yeah, we're good. Okay. So I'm gonna go ahead and run this next command. So this next one is we're gonna go Python 3 CLI tool generator.py, and then we're going to say generator, and we're going to say create, and then we pass in that scenario name. Okay, and the scenario name, if you remember, it was pinecone dash. This is where that FMIA space came in handy, right? Service. What was a container image? This is why container image. We actually really should just grab it from here. This one right here. Just grab it from here.
Yeah, application.
I'm making people sick by my jumping back and forth. Application fallback. Oh, unrecognized arguments image, like generator create.
Does it like your space?
No, I didn't. Did I pass it or anything? Let's see. Let's try Control C. Thanks. Python 3, 2, 1. There we go. Okay, so you see how it actually created it output that YAML for us right here with the response. So it does return the response to us. I could copy and paste that and toss it into a YAML file, but actually even better is I'm just going to go to S3.
Oh, so okay, so it pushes to the S3?
So it'll take that YAML. Like I can have it here if I want to, right?
Yeah.
But I like it that it pushes from S3 because my experiment generator will pull from S3 in order to do it. Let's see which one it was. Unfortunately, we got a couple places that I might have to check. No. I think our, there it is, right here, August 30th. So it just created this YAML file here, right? Now, unfortunately, my experiment generator doesn't have access to this S3 bucket, so I'm just going to move it really fast. Browse S3.
You mean your S3s aren't public to the world? Come on.
Oh my goodness, if only choose destination and move. Okay, so now I can come back to S3. Oh, too far. And this is the bucket that my experiment generator, my experiment executor, my experiment broker is actually going to pull this experiment from and now we run the test.
Okay.
And so I can go to EKS, and I think we're going to be good on time here.
We got 20 minutes.
Yeah, we're good. I did not mean to get off of that altogether because I'm going to need those values. And what I wanted to go is for set functions. So the way that the experiment broker works, and let me go back to the diagram here. Experiment broker actually is wrapped. I know it doesn't show it here. I have to pull up in another diagram that we have, but is actually wrapped in a step function. And the reason is because if you're running hundreds of test cases, first off, you cannot run them in parallel because chaos tests will interfere with each other, right? So they kind of actually have to go sequentially through the environment. So we wrapped experiment, and Lambda only runs for a maximum of 15 minutes anyway. So we wrapped it in a step function where you pass in a list of experiments to the step function, and then that will go through and it will run through all of those sequentially.
Okay.
Right. So you can basically give it a suite of experiments that you want it to execute. So that's kind of what's happening here. Utilizes Chaos Toolkit. It does have some SSM documents and things like that for failures if you want to do it on like the OS layer or whatever, right? All that's happening in Experiment Broker, but ultimately it happens here off of the Experiment Broker.
Got it.
So, go ahead.
The YAML file that's generated, is that the step function's YAML file that it uses?
No, that is the input to Experiment Broker to execute.
Okay. Yeah.
Okay. So what we pass in here, so what you'll see is, you come in and you pass in a payload. And the idea is that it's going to go through as many iterations of experiments as you pass it. So you pass it 100 experiments, 200, 1,000, doesn't matter. It's just going to go through them one at a time, right? executing through those. If you look at the payload on, actually, let's just do this. We'll just say new execution. So the payload is actually pretty simple. You started off in a pending state. When it finally gets to the last one, it's going to change its state to finished, right? And says, okay, I'm done, right? And it knows that that's how it's going to stop. The reason why we did that is because this is actually kind of a low-code solution. You don't need a Lambda function to sit here and like just check to see if you're done or not. Step functions can do that itself.
Yeah.
So we pass it in a state, and then we pass it in kind of this list. So you kind of see this list, and we give it an experiment source and a bucket name. And there's actually lots of different ways that we can do this, but this is just the easiest way for this one here. So we have that bucket name where we put it, right? And then I'm gonna grab pine cone, right? I'm gonna grab that object name. We're gonna pass it in.
And this kind of goes, Jerry kind of helped answer my question. This is what I meant, like, where does it run when I asked earlier, I guess. This is kind of what I meant.
This is where it runs, right? So like this is what actually executes that test.
Got it.
Okay. I think I just realized, I think there is one issue that's going to make this fail. Let's see. Oh,
bad code?
Probably. What probably is actually what it is if you remember, I made the change to, I added this action, but I didn't push this action to the Lambda function that actually executes it. I just pushed it to the generator. So we generated the YAML for this.
Oh, okay, yeah.
But we didn't actually, the Lambda function that actually takes that YAML and then executes this doesn't have this code.
Doesn't have it, yeah.
So that pipeline can take a little bit of time to run for everything to rebuild. And given that we're 20 minutes, I'm probably not going to go through that on this, but I think people hopefully kind of get the idea of how this all works. Yeah. What we just wanted to really kind of illustrate here, though, is that we love kind of the developer flow here, right? That really you create your actions, you create the corresponding mappings of what you need to do, and you just have to do it once, right? And then all of a sudden you can do this for as many applications as you need. Or, if you're looking at microservices, one of our applications has like 15 different containers that's running inside of this, different container types that are running inside of this application. And we don't have to generate 15 fallback test cases for them. We just had to generate one scenario method for that failure type, and make sure that the applications had in their proper container names, and all of it got generated, right? So we really reduced the amount of time it takes for the application team. The application team has to provide these details anyway. And we're able to just go auto-generate all of that, and we're off to the races. So it probably seems like a lot of work right now if you look at it as just like a one-off with a single service that's running. But if you start looking at the scale of applications that have dozens of services, it starts to make a lot of sense.
Yeah. Forgive me if we already covered this, but say we ran our tests and our experiment. Where do we see the output? Like that we were asserted true, or like we passed or not?
Yeah, that's a great question. So this one failed. I have to get that up. So what actually happens here, and there's kind of two aspects of this. I'll go back to here to kind of show it. Okay, so you execute your tests and everything. We typically store the results in two places. One is we'll store them in DynamoDB as a place for some people want them stored there as kind of the results. The way that we actually prefer to do it is actually to store them in OpenSearch. Oh,
okay.
So you take and whenever you run an experiment, part of Chaos Toolkit, and one of the reasons why we pick Chaos Toolkit as kind of the library that we would wrap for all of this custom code, is because it's just Python, right? It's that kind of testing as code piece. And if you remember, I talked about that at the beginning. We wanted something that was just very, very extendable, and this allowed for that. Well, anyway, it comes with this concept of a journal. And so you can basically add things to the journal, and that gets output as part of the Chaos Toolkit framework. And we send those results to OpenSearch. And then there's a Grafana dashboard that actually is reading those results and posting them on a Grafana dashboard for all the test cases, if they passed or failed, right, and the values that we want to present there. I can't show that right now on the call, but that's typically the way that we do it for our customers and what they like to see.
Okay. Awesome. Yeah, this is great. Like you said, especially like when you put it like you said, obviously this seems like we did an hour's worth of work, but you take that hour and you scale it out, and you end up saving tons and tons of time overall.
I'll give you an example of why this like made sense for us. So we had a customer who had, and actually I think I can stop sharing. I think we can pull down the screen at this point.
Yeah, sure.
So we had a customer who they had these 3 services, and they were services that were used by every other service, right? By all the other applications. So, and each service was just one container, was one container type and an RDS. And so we started looking at all the failure types that you could run there, and it was like, I think we had like 12 failures for the EC2 and another like 10 for the RDS. And so we had like 22 test scenarios for each set. So that was 66 across each of them. And that was just for one workflow. This technically was called in 11 different workflows. This one service. So 66 times by 11.
That is 618
something.
718.
Because it's so okay. Here's my cool trick. I don't know if I did it right, but whenever you want to multiply 2 digits by 11, add those 2 digits together and stick it in the middle. So like if you did 27 times 11, it's 297.
Okay.
Does that make sense? So 66 would be, it'd be 726.
726.
Yeah.
So anyway, it's just a huge number of test cases for 3 common services. If you wanted to go to that level of coverage that they required because of how critical their application is, right? Where there's like no downtime, no data loss. So we're just like, we can't do that with let's take the hour to write the one function, right? That will ultimately be run, all those different times, 33 times with just those 3 applications. So
that's quite a few.
So I have a question. So say I like what I see. I want to set it up myself on my AWS environment. How do I get started?
Yeah. So ideally, the links that you see in the chat is kind of where we're going to start, right? First, I would get started by getting Experiment Broker up and running, right? Go through Experiment Broker, make sure that you can get that up and running, that you have some custom code that you can execute against. You have to have an application that you actually want to test this against. Usually people know that. And then once you have Experiment Broker in place and you have like 1 or 2 just like manually created experiments, which you can just find online or you can create yourself, it's really not that difficult. And our documentation walks you through that. Then I would go get Experiment Generator up and running, right, as kind of the follow-up piece. And that's where we then, point you to the playbook and the blueprint that we have. And the playbook is kind of the Word doc that's going to walk you through all the services, the strategy behind what you're doing, and it'll have, the architecture diagrams. And then the blueprint is the actual code base. And that's the GitHub, the public GitHub repo that Vertical Relevance provides.
Yeah, and that makes sense to me. Like start with the broker and some of the stuff that's already, pre-built, baked in, pre-built, and then build out your own specific custom stuff as you need them with Generator. It'd be kind of odd to start building out test cases when you don't even have a way to run them.
Yeah, exactly.
So, yeah.
We always tell people that the first place to start is with Experiment Broker, then go to Generator, get those, and then you can get those 2 integrated. But you kind of want a place to start with. And then, FMIA, we do have one solution that I think it's called a Solution Spotlight for Resiliency. That goes into that's the strategy around everything, right? And that gets into FMIA and those pieces as well. So, you could possibly start by reading that. Then you go into Experiment Broker just to get the code base up and get that module running, and then the Generator afterwards.
Yeah. I was going to say, I've been trying to find, I was looking at Vertical Relevance in the AWS Marketplace. I see a financial services framework. This is something completely different, I think, right? Maybe we could get this into the AWS Marketplace as well.
We've actually been working on that. Experiment Broker is actually in the process right now of being
nice.
in the marketplace. Experiment Generator, relatively new, so that one has probably a little bit more to go to get in the marketplace. But Broker right now is, I think, currently in the review cycles for that.
Okay, cool. I was gonna say, hey Jerry, do we need some design wins or something to throw up on? Yeah,
Looks like they're already taking care of it, but
yeah. No, that's it. But that's good. That's a good answer for that, because I was like, where is it? Can I just marketplace it?
Can I just see that? Yeah. No,
Yeah.
we'd love to get this out there more. We've seen that customers really like it. They like how extendable it is. They like how easy it is to kind of, it's just Python. And when you say that, people are like, oh,
Yeah.
it's not that bad, right?
It's just pseudocode,
It's
basically.
just pseudocode. Yeah, yeah, exactly.
Awesome.
Pseudocode with white space.
Yeah, right. Well, thank you so much, Austin. Before we close out, Jim had to step out, it looks like. But is there anything else you'd like? I don't know if you know this, or maybe our little birdie in the backstage knows. Is Vertical Relevance attending any summits? Are we doing any conferences? Anything exciting that we can talk about real quick? Or
we're always at reInvent. Beginning this year, we actually did a kind of a resiliency conference out in New York for a little bit that we co-hosted with AWS, which was great for some of our financial services customers out there. And so, we're looking to do some of those things. And if we do any specific events, I'm sure that we'll reach out. But kind of the big one is just reach out to us, right? If there's interest, if you like what you see, right? We're happy to have conversations and kind of drive and see where we go next with this. We have other solutions we didn't even get to in this space that we're really excited about, right? That we're kind of developing and pushing forward. So, if you like this and you're kind of wanting to see what's next, where are we going forward? How do we drive this for these huge enterprises to adopt these kinds of things? We have lots of thoughts, lots of conversations. But yeah, I think probably the next big conference we'll be at is in Vegas in November. For sure.
Nice. Yeah, if you're there, I'll see you there. I'll come stop by the booth. I'm going to be there the whole week. So, for better or for worse, some people may be happy about it. Some people might not. But whatever. You got to take what you can get.
That's right.
Is there anything you'd like to plug? Like I always say, do you have your dog on Instagram or anything like that?
I wish I did. Nothing. Nothing comes. We just started watching a dog for the next 3 months at my house. So let's see if that goes up for sale soon or not.
Chance. Awesome, cool. Jerry, anything from you before we close out? We got like a minute or two.
No, nothing for me. This was great. I got to see it in action.
Cool. What do we got here? Chief Resilience Officer. That's what I'm hearing. Something like that.
Yeah, that's true. I've been joking around that eventually you're going to see a CRO, and I'm trying to get my hat in the running for that. So, if you happen to be like the president, the CEO of, some major corporation and are looking for a chief resiliency officer, I'll plug my name there. Yeah.
Well, okay. You got my vote.
CEO, but you got my vote. Exactly.
Cool. Well, thank you so much. One last time, let's put that. If you can take our survey, not just for Howdy Partner, but also for VR. If you want to give us their email, I can pass it on to them. Connect with them. I've been dropping it all throughout. You can connect with them on LinkedIn. You can connect with them just through their website. Pull down those repos. Contribute to those repos. If there's anything you think, we always at AWS, our customer work backwards from the customer. Sometimes the customer wants something and they just want to take it into their own hands. Just contribute do a pull request, send that in, and Austin will approve it, right? Just
That's
like
it.
that.
I don't just LGTM. I don't even look at it. I just
approve. Yeah, just click. Yeah. Cool. All right. Well, then, thank you all very much. Next week on Howdy Partner, we're having PagerDuty. I'm excited to see that, even though I've had on-call flashbacks of PagerDuty. So, but that will be fun. So tune in next week for that. And with that, I will take us out. And everyone have a great day. Please connect with us. Please take our survey. And we'll see you next time. All right? Have a good one.
Cheers.